Okay, here's a model of the planetary gears. And I'm going to show you this output, this ring gear on the outside is called a ring gear. And it is what the um, traction motor, some would call MG2, the traction motor, is connected to this at all times. So when this is turning, the traction motor and the wheels are turning. So this is the wheels and the traction motor. Then this blue, which I'm going to move this a little bit here so you can see it. There's a white thing so you can watch how that turns around when we're talking here in a minute. The blue is connected to the gasoline engine. The gasoline engine, when it turns, you'll see these blue gears turning. And then the red, the gear in the middle, is called a sun gear. These are the planet carrier, the transmission, or the blue gears, and the gasoline engine. Those gears are called the planet carrier. The red gear here in the middle is the sun gear, and it's connected to that small starter generator motor, which also is the motor that changes the gear ratio between the engine and the wheels. And we'll see that in a minute. If we look at each of the situations, let's first look at the engines running, but the car's parked. The car's sitting still. So the engine is turning. So if I turn the engine, the blue gears, you'll notice the red gear. If I turn the red gear, for instance, if this is rotating at a speed that one little increment of time gets it to turn 90 degrees here down this way. If the sun gear were to turn 3 times as fast as the gasoline engine is turning, that would put it in that same time period all the way over here. And you'll see that what has happened is the wheels have not turned. So we'll look at that again. So we start there and we begin going like this with the sun gear, or the planetary gear. I mean the sun gear and the MG1, I'll call the starter generator, turning at a faster rate, is the wheels do not turn. So by running MG1, the starter generator, 3 times as fast as the gasoline engine is running, the wheels are stationary. Now, if the engine is off, and you're driving your car down the road, maybe forwards, maybe backwards. That's the other thing about this I didn't mention, is since MG2, the traction motor, is connected directly to the wheels, if you want to go in reverse, it just runs in the reverse direction. So electric motor, you can run it forward, you can run it backwards. So reverse is just that motor running backwards. But if it's running, let's say you're going down the road, then that means this outside part, which is basically the wheels and the motor, and the MG2, moving this direction, is forward. If this is the wheels, that's the front of the car that way, and so it's turning this way like this, and so if it's running like this and the engine is off, you'll notice that the I'm gonna turn the wheels, that red dot, I'm gonna turn all one time all the way around. You'll notice that the uh, MG1, the starter generator, is turning. Before now, when we were doing this, it was turning that direction, turning forward. So now, if we're turning the wheels and we don't want the engine to run, MG1, the starter motor, is running backwards. It runs in the other direction, and you'll see it's taken a full revolution all the way around once for the wheels turning around a half. So it's running backwards at twice the speed of the wheels and MG2. So by having this control motor, which is the MG1, running at twice the speed backwards, then you can drive the car down the road using the electric motor, and the gasoline engine is not running at all. Now, if you're parked and you want to start the car, that is the starter generator. So um, you can start the you can start the car by and the other thing to remember now is the gasoline engine, the motors can run either direction. The gasoline engine cannot. It can only go this direction. So if you want to start it, if you turn, I'm going to turn just, I'm not even touching the gasoline engine. I'm only going to turn the MG1, the starter generator. If you'll notice, is if I just turn that, I can run that at whatever speed I need to, and that's turning the gasoline engine, and that starts it. You can start it. Now, once the gasoline engine is started, okay, I can continue to have it started, and you'll see that at 3 times with the gasoline engine running, the starter generator is running 3 times faster. So here's if I watch this sun gear, the starter generator, all the way around one time, the gasoline engines only run a third. So it's 3 to 1. And so you can use that to turn it into a generator to charge the battery. So while the gasoline engine is running, that starter generator can be used. Just setting still, the car is not moving. Gasoline engine can be charging. And actually, at any time the gasoline engine is running, you can have this starter generator in generation mode, and it's charging the battery if it needs to be. So if you're driving down the road, you can have everything moving at the same speed. That's a 1-to-1, and they're all running the same RPM, and you can use that to generate electricity or to charge the battery if you wish. Uh, if the car thinks it needs to. None of this is what you're doing. The computer's always deciding this. But so you can see as we mentioned before, you can have the gasoline engine running, and you'll see that as long as the sun gear, as long as MG1 is moving at 3 times the speed, the wheels don't turn. If MG1 moves at the same rate as the gasoline engine, it's not 3-to-1 anymore. It's 1-to-1. The wheels turn the same direction, same amount as the gasoline engine. within uh, this power split planetary gear set. If we turn the MG1, the starter generator, at twice the RPM of the gasoline engine, you'll notice that the ring gear that drives the wheels went half as far. Gasoline engine is running at this RPM, and that same increment in time that it took it to get a halfway around, the ring gear went a fourth of the way around. So, and it did that because we ran the sun gear, MG1, we ran all the way around. Now we go back over here and start again. Now, if I run the sun gear only part way, if I run gasoline engine halfway around, and the sun gear is running at half that speed, so that increment in time where the gasoline engine turned that far, the sun gear and the MG1 only went this far. So if it's running half the speed instead of twice the speed, instead of the wheels turning a fourth of the way, they turned 2/3. So there now the ratio is going faster than the wheels are moving. The wheels, the ring gear that drives the wheels is now running faster than the gasoline engine it's because this gear, the sun gear and MG1, is running slower. So you can see, you can come up with any ratio you want. I'll get this back over here. Get it set up again. There you go. You can run any ratio you want, and including, like I say, including having the wheels turn backwards. If I turn backwards, let's try that. I'm going to run the gasoline engine an increment in time where it turns one halfway around. And if I didn't turn the MG1, which is the starter generator, if I have it stopped, then the gasoline engine went around here half the turn in that increment of time, and the wheels went even more so. They went all the way 3/4 of the way around. So they're moving faster yet. And if I had turned the MG1 sun gear, if I had turned it halfway around, but in the opposite direction, then these wheels would have gone all the way around, so even faster. So you can get any ratio you want by moving this sun gear, the MG1, at rates of speed in either direction, or none, or exactly the same as the engine. You can get any gear ratio you want. And that's the way the planetary gear system works. That's why you don't have to have a clutch to disconnect everything, like conventional transmissions do. All you have to do is have control of the sun gear. And in order for this to work, you have to know exactly what speed the engine is going and what speed the wheels are going. So there are sensors in the MKZ hybrid that senses all these speeds right down to a fraction of an RPM, so that the computer can determine exactly how fast to drive each of these motors to get the car to do whatever it is you want. I mean, a typical example of that is, of course, if you're trying to hold the car still uh, without your foot on the brake, but the engine's running, and you can do that. But it has to be exactly, it has to know exactly what's going on speed wise of all the components.